Okay, so here's video number 2, and you've tried the Königsberg bridge problem, and by now you probably understand and realise that no, it's not possible to solve this problem. You can't start in one place and finish up back where you started, crossing every bridge only once. It's impossible. Now, Euler was the one who proved that this was true. So let's discuss how we know that it's true that the Königsberg bridge problem can't be solved, with a discussion of Eulerian circuits and paths named after Euler. Okay, now two definitions to start with here: a path and a circuit. Now, a path is a connected sequence through a network. So here the path is described down below where I'm underlining. Okay. That path is A to B, so we go A to B, then to D, then to C. Okay, so that's a connected sequence. We don't end up back where we started. Now for a circuit, we do end up back where we started. So here this circuit is A, B, D, E, A. A, B, D, E, A. That's a circuit because we start and finish at A. Now, if you can draw a circuit without lifting your pen from the page and going on every single edge, then that's an Eulerian circuit. All right, so this one here we go A to B to C to D, back to B, back to D, to E to A. So I crossed every edge only once, and I started and finished at A. That's an Eulerian circuit. Another good example is an envelope. Can you draw an envelope without taking your pen off the page? Okay, I'm going to go down, across, up, down, down, and down. And yes, I can draw an envelope shape. But of course, in this one, I started here and I finished here. So that's what we call an Eulerian path, because we touched every edge in the network, but we started and finished in different places. Okay, so you might want to try these. Pause the video and see if you can find Eulerian circuits and paths for each of these ones, and then I'll show you. Okay, I'm going to have a go at it now. Right, so can I get an Eulerian circuit here? I'm going to start at A. Right, so I'm going to go A to B. So I'll write this down as I go. And then from B to C, then to D, then to E. Now from E I'm going to go to B, then to D, back around to E, and then finally A. So yes, I can do this. You might have found a different one that works, and that's okay. Sometimes there's more than one circuit. Alright, now can we do this one? Alright, so remember we need to be able to go along every edge without lifting our pen from the page. Alright, so I'm going to try this and then write down the circuit. A to B to C to D to E, back to A. Then I'll make the star in here, and the da, da, da. Yes, I did it. So I went A to B to C to D to E, which is around the outside of the shape. Then I went back to A here. Then I went to C to E to B to D and back to A. So there's an Eulerian circuit. Okay. Now this last one, you may have tried this and you couldn't get an Eulerian circuit. That's true, and with experience you'll be able to see that that's a fact. I'll talk more about that later on, how you can tell straight away. but no Eulerian circuit is possible here. But we can get an Eulerian path. If I go A to B to C to D to E to A, oh, that doesn't work, sorry, I'll try again. So a bit of trial and error sometimes is required. Okay, all right, yeah, now I know what I did wrong. I'm going to start at C instead this time. So I'm going to start at C and go to E to D to C. And then B, A, E. Now I've touched every edge once only, but I started at C and finished at E. So that's an Eulerian path. These two were Eulerian circuits. For these two. Okay, so try the questions in the set now for Eulerian circuits and paths.